This is the Financial Thought Exchange podcast, where you learn from the leading thinkers in finance. I'm your host, Lotta Moberg, and my guest today is Francesco Fabozzi, Managing Director of the Journal of Financial Data Science, and also a researcher in fields such as the application of large language models, natural language processing, and machine learning in investment management. He is here also as the author of the piece Natural Language Processing, which is a chapter in our publication AI in Asset Management that came out recently. So make sure you picked it up. And Francesco, thank you so much for being with us today. And also thank you so much for writing this interesting piece.
Thank you for having me.
Yeah, we really appreciate this contribution. And I know everybody's reading both your chapter and other chapters in this publication are really appreciating it. So if you haven't seen it already, make sure to pick it up online. Now, we talked, in case you haven't, if you missed it, this is the second out of two conversations. And the first one, we covered quite a lot of the technical background and understanding what we're talking about natural language processing and so on generally, as well as in finance. And we want to get in a little bit more on the finance side today. So, uh, just if I think about, say, we have a financial operation here, a financial firm, and they want to have their own LLM, right? To focus on some kind of task that they engage in, and they want to make this task quicker, maybe easier for themselves. Maybe for this context, for people who are starting to look into these kind of projects, it would be good to understand when are you engaging in pre-training of these models that you're creating, and when are we talking about fine-tuning? Because those words pop up a lot.
Yeah, yeah, this is a good question. So the pre-training is sort of this is really we leave this to these large tech companies that are building, foundation models. So the outcome of pre-training is a foundation model, right? So these are sort of all these popular models you see on benchmarks. You have Llama, you have GPT. Um, these are the sort of the pre-train the outcome of the pre-training, the foundation models. And this doesn't include sort of all of the tools that they use and can search the internet. No, this is just the models, sort of pure intelligence, after training on a whole world of text, right? So you're training on everything to try to make the model as smart as possible, have the most experience possible. Now, fine tuning is what we sort of do in finance, where we are more consumers of these foundation models, and we will fine tune the model to sort of behave in the manner that we expect. And this could be fine tuning anything from you have a proprietary code base, right? And so you want to make the model more accustomed to your code base. So you might fine tune on that. Although maybe that's a bad example because now people are sort of looking at how do you use sort of RAG based approaches, which I'm sure we'll get to later. But fine tuning could be also be for like a return prediction. So something that I've discussed in my research and created techniques for taking a generative language model and it has some understanding of what like sentiment is and news, right? So you could ask a pre-trained foundation model, what is the sentiment of this news article? And it'll probably respond very similarly to what a human does. But you could also fine tune the model to understand sentiment as actual returns, right? So if we have a bunch of news articles and we can say that there was a positive return after that news article or a negative return after that news article, or sort of it stayed flat, we could use that to represent what positive, neutral, and negative means. And now train the model to predict sort of on those sentiment labels that are based on returns. We could now train the model to predict returns based on, um, the actual returns itself, but through this natural language processing approach. So, say having a complete what is the sentiment of this news article? Give it news article, then ask for its response. You can train now to understand that, to train to predict positive, neutral, or negative with a fine-tuned model based on returns, or with a foundation model, which is going to pick up on more generic sentiment.
Right. So if it helps when, like you say, there's a generic, there is possibility that would be a generic versus a very precise and factual question. And in your example, what's the sentiment? So if I'm a policy analyst think tank, I might want to know, well, the sentiment is that, left-wing policies are better for humanity. Versus I don't care about that. I'm a finance person. I want to get the sentiment, like you say, about that
Mhm,
people should probably not buy the stocks or the goods of this company, and therefore we should be careful.
mhm.
100%. Okay. Yeah,
Yeah.
so kind of like imposes an interest of focus. Good say.
Yeah. And I think another way to think about it is you use this when prompt engineering fails too. So one of the projects that we had at Yale during my time there was we would look at extracting history from news, references to historical market events. And then this would allow us to, the objective um, was to then look at, if investors behave irrationally or rationally, but, related to sort of new events that are related to history, how do they react? And in doing this, I was developing the model to extract these historical events. And we noticed that, you know, these cheaper GPT models that would cost, like that would still be pretty costly to run, um, it would cost like $10,000 to go through our our corpus of news articles, and it still wasn't doing a good job, right? So what we did was we actually took a small open source model because we had access to compute and generated about, you know 200 examples of the most sophisticated model extracting text from these news articles. And we just trained this small model to behave like this larger model. So it was also an efficiency standpoint. So we couldn't really prompt engineer this small model to do it. So we had to then fine tune the model to do it, which we did by doing this like teacher learner uh, knowledge distillation approach from a larger model to a smaller model. So really when prompt engineering fails, that's a good place to decide if you want to fine tune.
So it sounds like it is very simple, similar to, I was just thinking about, I write a prompt, then I am prompting it to look for the things I care about, right? Uh,
Mm,
what is the difference then between prompt engineering probably should explain too. So prompt versus prompt engineer, and then prompt engineer
mhm.
versus fine tuning is still not quite clear, right?
Yeah. Yeah, so let's suppose that we have, another example from work at Yale is suppose that we have, we're telling the model, we want to get emotional sort of scores. We want to get scores of emotions from a piece of text. So we want to see how happy, how sad, sort of the range of emotions. We want to sort of get scores for, and understanding this. And, we can prompt the model to say, please provide a score for each of these emotions, blah, blah, blah. And then if we were to compare that model to, if we were to compare those scores to human scores, we'd notice that the model is sort of identifiably different from, a human scoring the text, right?
Mhm.
And there's nothing you can really give a prompt that is going to tell the model to be more human or to really be like, oh no, you're overestimating happy. Now you're overestimating happiness, underestimating sadness. Well, now you're biasing the model, and like now you're sort of not really getting at the point of modeling for emotions. You're just directing it. So, like in order to make it more behave more human, we can't really distill all of that in a prompt. We can't give it our emotional experiences and say, here's how you should score this. But what we can do is let's take the human annotators and try to have the model behave more like that. Right? So there's nothing in the prompt that we could do to tell it to behave more like these humans without biasing it, but we can fine tune it on a large amount of examples that now we can have the model behave more like a human. So that would be an example of fine tuning. Sort of when you can't really get the model to budge, but you have some of the right answers that you can try to teach it.
So I'm sure everybody who's listened to our prior conversation is wondering right now, hearing you talk, is this an decoder or an encoder thing? So if you don't know what that is, we covered it in our prior conversation. It sounds like we're talking about encoder, but I'm not really sure. Anyway, keep
So
it when we're talking about fine tuning, that is.
we're talking about decoding in this example. So uh, if it's generating text, like if the goal is to generate text,
Mhm.
output as text is output, then it's you could assume decoder only, right? I mean, most of modern day conversations have really centered around decoder only architectures. Again, the prediction, next token prediction. That is, how do you generate output text from the model? Whereas encoder, now you're sort of getting latent vectors that you're using to sort of represent text as a whole, and then some latent understanding there. Um, but yeah. So in this case, since we were training the model to sort of predict emotions in a text-based framework, this would be the decoder only. And that's where a lot of people are talking about fine tuning. You can fine tune encoder only, but people aren't really focusing on that too much right now.
And now you mentioned RAG. So RAG is a acronym, RAG, and maybe you can explain what does it stand for, and and yes, that's another one that we might end up getting mixed in the soup of the words here in
Hmm.
terms of making a model better. So what's the difference between a
Yeah.
RAG now and a fine tuning? Sounds like they could be similar.
Yeah, so RAG is now actually more like a retrieval augmented generation. So this will actually now use both encoder decoder because there's a retrieval part of the. So for example, if we want to have some automated process, right? You want a model that can read all of your internal documents and answer you, right? Um, you'll have a retrieval system, which is basically these vector embeddings of text that we can measure cosine similarity with a database of these vectors that will then say this is the most similar article to your question. Let me pull this into the context of the model in formulating the prompt. So I might have some RAG is now where we're getting to more systems. I would say so like fine tuning pre-training that's operating on like the individual language model level. Now we're getting into more agentic, we'll call it for now, agentic like frameworks where you're getting now a system that is being orchestrated by a language model. So it's saying, go get this relevant piece of text and now bring it to me so that I can have this information readily available while I answer the user's query. So what was our latest report on Apple, and how does that affect our decision making here? Well, the model then says, let me retrieve something, right? And then some information that it wasn't trained on, some information that it wouldn't know or wouldn't have to store out of, remember really. It can just retrieve it and put it there. So like if I were to ask you, what was you know, what was your last or you have a flight coming up and I said, what time's your flight? And you say, oh, it's at noon, right? But it's really like 12:10, right? If you pick up your phone and you look, right, that's you're retrieving the information as opposed to just memorizing it and maybe hallucinating a bit because you're not remembering it exactly, the exact time, right?
And it's the retrieval, that's like more like the RAG.
Yeah, yeah. So the retrieval, so it would operate on more foundation models, right? The foundation model can like answer the question, but you have to give it the right context, right? And if you try to make it operate solely out of sort of its memory of the pre-training process, then it's likely to hallucinate. That's why these systems are coming about such that we can give the model the most relevant context for answering a certain question. And that's more of a RAG based approach.
So very different to here, use this text to give me a good answer or ask about a specific document right now. The system actually knows where to
Hmm.
go and get the document. So this
Yeah.
title leads us into what we talk about agentic, maybe. I don't know if RAG will
Yeah.
be agentic, but what do we mean
Yeah.
by what's the kind of level of independence here for us to say
Hmm.
that something is agentic? Because that's a word here a lot too. What is it?
Yeah. Yeah. And so just one more point on the
Mhm.
the
Sure.
RAG part is, you know, in finance, it's really important because the big challenge of this was how do we finances it's not like law, right? Where we're acting on past precedent, right? Inherently, we want to act on past precedents. We now have in finance, it's very easy it's very hard to retrain these models and information is constantly changing. So if you were to have a pre-trained model and you asked, what is the most recent earnings from Apple? Well, if you stop training the model in 2019 and you don't have a RAG approach that can retrieve the latest information, well, it's now going to tell you, the most recent from the last time it was trained, right? So that's sort of like the importance in finance. So now we're getting to agentic to get to the agentic and where this fits in. Um, this is sort of being the terminology people are using like interchangeably, but as sort of these systems are developing, people agentic is sort of straying away from solely just RAG based, right? So a RAG based would be here's your database that you could select from. Here is your here's how you retrieve it. This is RAG where it's like, okay, just retrieve the most recent document, the most relevant document from this database and use it to answer this question. Agentic approaches are now more of this planning architecture, right? So it's less directed point A, point B, point C in this sort of agent based system. An agentic approach is now here are all the tools that you have available to you. Look at this user query, select which tools you want or that you think are necessary to answer the question, come back to me with your results, right? So this is sort of like the RAG part um within an agentic system. Come back to me with your results, and now I'll sort of curate all this information to answer the user's query. It'll evaluate whether or not sufficient information came back and say, you know what, I actually need to call another tool, which could be, some code, some, price feed API, any sort of custom logic you've built. Oh, run a var on our code base, run var. Um, these things are the model will know how to sort of orchestrate a whole system of these what they call tools and tool calling um that you supplement the agent with. So it's more of organizing its own sort of uh, approach. We're not telling it, here is your very limited options you can do. Here's sort of access to everything, we have access to, as a human. Now figure out how to answer the question. And if your initial steps don't work, go back, rethink, replan, and try again.
Yeah, well, that's clear. You did mention hallucinations here, and this is a big question, of course, in finance, anywhere really, law, like you said, but just anywhere. And in the sense of, so I'll have a library, right? Like here, are all these like documents and documentations and the companies that we invested in our firm and stuff like that, right? And as you say, you need a rag or something, like that, and that could be agentic to incorporate. Now, if I want to ask, like, what's the implication of the latest Chilean election on my portfolio? Well, then I need to know what the outcome of that election and possibly what that politician has said before that person won and things like that.
Mhm.
So, of all these things, right? Like, where does hallucination come in? And is there any way to avoid hallucinations? Because it sounds like if I'm just saying, okay, here's the library, read this. You may only answer from this. There should be no risk of hallucination. But as I understand, it's almost impossible to be completely foolproof from this. Or
Yeah, yeah, that's totally true. Think so hallucinations, right? While we have, right, you could provide the source documents, to be able to tell them out. Sometimes it might not focus on the right thing, right? So if we're not very clear in our interest, think about if I gave you some, we took the AI handbook to read, right? And you really understood it at this very high level. You really took your time to read it, and you thoroughly read through it. But then I was like, asked you, do you know what the footnote on page 20 said? Right. But when you were reading that, you weren't really thinking, let me retain what was the footnote on page 20, right? So without proper ways to sort of isolate that, go back and think, once it has already read it once, right, it might not have retained that information and might be like, okay, well, page 20 that we were roughly talking about this. I remember this footnote. Let me just spit it out to the user. So, a good agentic approach would think, okay, well, I don't remember this. Let me go back and collect this text. But now you're getting to, as you have to do more and more of these things internally, connect a bunch of pieces together, like you could be super thorough, but you might take, 10 minutes to get your answer, 20 minutes, 10, 20 minutes to get your answer by thoroughly, sort of rechecking everything. Or we could get you sort of a almost, very close to not, perfect text in a minute response. So it's sort of this optimization between, time to response versus how thorough you can make sort of these thought processes, right? So in a very practical example is, okay, let me summarize the news for a given stock on a certain day. Now, I could just append all of the news articles together, right? And have it all in one prompt and have the model summarize everything. Or I could now have a bunch of different models summarizing each individual um, news article, synthesize that into a summary. That's just gonna take a little bit longer, right? This is, that's pretty trivial timing, but as you build systems, these things sort of propagate and you have a bunch of these things where you're like, should I run one article at a time to make sure that I'm like sort of mitigating hallucinations? Could I even add another layer in the middle that's now I'll sort of aggregate them by topics, summarize one topic where I send all the news pertaining to this one topic all in one chunk, the summaries all together, have it another summary, sort of having a tree of summaries. That would probably make sure that there's zero hallucinations, but it might be overkill and take a lot longer than sort of piecing things together. So it's really sort of a architectural thing, and users aren't as patient as they think they might be to get a perfect answer.
Yeah, well, that's interesting to hear that there's that trade-off, right? And it's
Yeah.
time. I'm guessing it's also tokens, so which means money if you're paying by token as an operation. I mean, I can
Yeah.
certainly imagine that, like, if I one day get HR tells me that my assistant has now been replaced by a robot, and the robot is now sitting by the assistant or my analyst desk, right? And I ask that robot to do something, I would be perfectly fine to say, "Take your time, I'll go for lunch, 2 hours later."
Mm,
And good response, right? At least that's how we used to be
yeah.
working rather than getting a half-assed response, in the second. So,
Mhm.
yeah. So
Yeah,
we
yeah, but the token, yeah, yeah, you mentioned the token. That's like really what these large tech companies are sort of optimizing for, is they're taking like a ChatGPT. They're sort of formulating of their context. They're doing it trying to fit the most information in the smallest amount of text. There's certain, techniques that they have for doing this, sort of like a human, of having long-term memory, right? So I'm going to remember things about you as the user across all of your interactions. Like, you know, when you ask for this, you actually like your report like this, even though they don't explicitly say it. Like, after they yelled at me a lot, now I'm sort of putting this into my long-term memory bank. And then there's sort of this short-term memory bank where it'll be sort of these like RAG type information that you're pulling that are relevant to sort of the context of the conversation you're having now. And there's really just a lot of interesting things that they're doing to, it's more or less simulating, human memory and human being more human like, because we forget things in the short term, right, that don't matter. We sort of drop that information, but then we have certain things that stick with us that we put in our more long-term memory bank. um yeah.
Yeah, and I think people will be surprised by thinking about a computer that forgets. It's like, it's
Yeah.
there, human I will
Yeah.
forget for, forgetting my birthday, but if I told the computer once that this is my birthday, I'll be like, "No, can't get
Yeah.
that wrong." But,
For memory efficiency, they say, humans have this ability, right? As we were learning more about sort of the human mind and trying to model the human mind, they say actually that, this forgetfulness of sort of shorter term context, it's a feature, not a flaw. So that we don't, sort of overburden our memory banks, like we don't need as much RAM, you know.
And so while we're on the topic of humans then, we did talk about the agentic framework, but there's also the concept of autonomous agents. So this seems to be like a hyper version of agentic framework, or when do we cross the line to call something that autonomous?
Yeah. Yeah, that's yeah, so it's, I guess that's where you go from, right? I guess we would consider like RAG being on the lowest end of a sort of agentic framework, and these autonomous agents being at the other end of the spectrum, um, of an agentic approach. So autonomous is, really enabling this thinking process that I had described before. So the idea that we're gonna give it all these tools. You're gonna have internet access. You're gonna be able to, I guess, in the realm of finance, be able to trade on your own, right? I don't think we're there yet, but in theory, you'd be able to trade on your own. You know, you can run risk reports. You can here's the emails of our investors such that you can send reports. Oh, and it knows based on a prompt, or it will then like prompt itself. Hey, did you know we have a report coming up for our investors? Oh, let me go do that. Let me send off a couple of these. I have these tools that I can call, right? I'll need to access our performance data. I'll need to access our reporting framework, and I will need to access our user databases, or our sort of investor email list. Okay. let me go now run this. You guys go run this. Oh, do we what's happening in the news today? It'll prompt itself to do these things, right? So it has to be,
Right.
it comes to having a good orchestrator, right? You need a good model that can orchestrate all the analytics, and almost like a project or a product manager, right? A project manager where they send off, they're not overly getting involved in sort of these sub agents in their, they're not getting involved in other people's work, right? They're sort of giving guidance and saying, come back to me when you've sort of formulated things well enough such that I can interpret it and use it. So this is now, this orchestrator agent is now the thing that is going to, really be like the PM in a finance sort of framework, right? So, and that's just got to be able to ask the right questions, be able to use the information that is being given, and understanding the goal of sort of this system. And now here's where the problem that is being solved for now is, now that it can do all these things, it might do all these things and be overkill where it took like 20 different steps to accomplish something that could have been done in, you know, 3 steps, right? Since it has this sort of, it can converge to the answer, but slowly, right? Where, so that's sort of what people in this space are trying to optimize for, using some sort of like reinforcement learning techniques to be able to do so.
What are the applications, if any, do you know of in that is happening in the finance space now with using these agentic frameworks?
Yeah, these agentic frameworks, I would say, you have, I think some of the more interesting stuff, right? So again, it's this spectrum, right? So we have a lot of discretionary fundamental managers who are basically getting research done and using the
Mm.
as a research tool, as a research analyst. There's a lot of these sort of consumer chat bots that can access API, price API feeds, look at the news, read earnings reports, read internal company um, company proprietary information, and synthesize these things and sort of orchestrate which things that it needs to call, right? It's not fully autonomous because we're still having its ultimate goal is to get relevant research back to the portfolio manager. Um, and that's really the extent of, how autonomous it is right now. I'm sure there might be people experimenting with, um, autonomous portfolios. Yeah, I don't think that there are, huge portfolios that are dedicated to this, but I'm sure there's some experimentation going on of letting a model just run and seeing how it does. Um, but then there are, and that's probably actually more in the open source sphere because there's a lot of liability that comes when from a large firm doing this. Um, but then another sort of interesting approach to give both sides of the coin in the quant space, there's they're doing similar things, but there's also now this proprietary code base that has been developed over so many years from these companies that now you can have more non-technical people starting to code, maybe people who are more experts in the markets can now just back test their hypotheses. They can back test their hypotheses without sort of needing a intervention from a more quantitative person, right? So it already knows that it can pull from a code base that has a bunch of examples of back tests that the quants have already made. Well, let me try to help this person back test and formulate their investment idea, you know, quantitatively. So that's another aspect of sort of these agentic approaches.
To clarify that, so as an example, we have a model, say that this is going to be a very novel model I'm going to come up with, but it returns on the stock, it depends on the earnings, right? So that's our regression model, and that's very sophisticated, and it's been
Mhm.
coded in there. And I'm thinking, oh, maybe the age of the CEO also matters, and then I want to put it in there. In the past, I would have needed to understand how I changed the code myself and understand where the regression goes and how to find it and stuff like that. And now I could just ask whatever application we have put on this, the AI to, "Hey, add this parameter in the same way that you added the earnings parameter," for example.
Yeah, yeah, and it would simply go to a right. So now there's almost more collaboration amongst also within the quant where you'll have okay, here's our the agent would know here is our feature bank. Here is all of the features that we've created across all of our quant products. Which one do you want to slot in there? Oh, okay. Well, this person wants CEO age. Okay, well, let me just go pull that, bring it into my environment. Oh, here's the code to get that. All right. It's fairly simple now for the model to do that. You don't have to go to the quant and be like, how'd you formulate your CEO age variable? Or like, what was your source for this? I want to start incorporating that here. Uh, and then they maybe send you a code base that you kind of don't understand at all, right? And it's going to take you, a week to parse through it. The model already understands what's going on. Also, as you code more with AI, this it's converging towards like a standardized format um it of the code bases. So it's really writing the code as well. So now it's sort of already understanding. It's not like it's dealing with some sloppy code base that someone wrote with all these coding assistants right now. It's standardizing the way in which code is formulated so it can easily digest, new code bases on the fly. Um, yeah, the coding agentic space is really taken off. It's pretty remarkable some of the things that you can do with these coding agents now.
And so we already seeing things happening then in the finance space. What are some of the applications of language processing models, generally agentic or not, that you're excited about and you think maybe underrated at this point that you would anticipate seeing more of?
The thing that I'm so surprised is not I think that they're starting to uh I'm not recalling the exact but I think we're starting to go down this line, but is general price encoders, they're general price transformers. Yeah, the GPT actually same acronym. But I've been so surprised that and I haven't dove into this research myself as much, but is we have all these price feeds. What is a language model? A language model is predicting the next token, predicting the next word in English language, which is a very, very complicated task. And well, what are we trying to do all the time is predict the next return, right? Whether it's sort of discrete up or down or sort of more continuous where we're trying to predict, a continuous value. That's a little bit harder of a problem, but we can have these sort of general price transformers that will allow us to predict the next price based on we have all of these time series readily available. We could go back to even modeling the most obscure price patterns in history and seeing how that relates to the future. So I think the reason why so people in the literature they've been saying that this is more of like recurrent neural networks and these sequential neural networks are actually much better than transformers at this task. And but you look at it and it's really training a transformer model on sort of one time series at a time, right? As opposed to doing an open AI like scale of training on all time series, having all of the time series available in the world to train on that. And now, you know, based on the time series, the it could probably tell you, okay, this is a commodity. Like, let me sort of, yeah, I've seen this pattern before. This is the likely next trend. I think that's just to write off transformers for price return prediction based on previous prices is I think we haven't utilized transformers to their fullest capability. We're sort of doing it in these smaller one-off tests as opposed to someone who's going to take on a project of I'm going to collect every price return series in in history and now train a model on this. So I think that's super exciting, solely in the realm of finance.
No, that's fascinating. Oh, I want to thank you so much because I learned a lot about just both how these things work and what's possible out there today and in the future. So thank you so much, Francesco Fabozzi, for joining us today.
Yeah, thank you, Lotta. I appreciate you having me. Glad to
This was
talk
a lot
about
of
these
fun.
things. Yeah.
And in case you missed it, this was actually the second out of two conversations. So there is another conversation to click on our YouTube channel and elsewhere, wherever you find this video, where we cover a little bit more on the technical front of this. And with that, I thank you everyone so much for tuning in. This has been the Financial Thought Exchange podcast. Your host here is Lotta Moberg. And our guest today was Francesco Fabozzi. He's the author of Natural Language Processing, which is part of our publication AI in Asset Management. Thank you so much and see you next time.
For more information, please visit rpc.cfainstitute.org/research-foundation.